Well, our last section of chapter 3 has to do with coming up with the equation for a line. One of the things we're going to work with to start off with is that same y equals mx plus b form that we saw last time when we talked about slope. Remember that it's called slope-intercept form because the m number there tells us the slope of the line, and the b number there tells us the y-intercept of the line. So if you have a picture of a line and you're able to tell the slope, maybe by a rise over run like we did last time, and you're able to tell the y-intercept, it would be really easy to put those numbers in and write the equation. Like the first example we see down below here, there's a picture, a graph of the line, and we're asked to write the equation. So if we could look at the graph and figure out the slope and the y-intercept, we could just fill those numbers in, and we have it. The y-intercept is going to be the quick and easy part. Remember, we just want to look to see where the line crosses the y-axis. So it looks like in this case, it's the dot there, halfway between the 0 and the 10. So in other words, the y-intercept of that one is 5. That means where the b is in the equation, we're going to put a 5 instead. So it's sort of starting to take shape. We know it's going to be y equals something x plus 5. The something we don't know yet is the slope. So kind of like last time, we have a few different slope formulas to choose from. Maybe identifying 2 points and using the x's and y's would be your choice. That would be fine. Like this highest dot on the line here, it looks like it would have an x value of 15 and a y value of 15. And then we already saw that the y-intercept there is at 5 on the y-axis, so that'd be the point 0, 5. We could use our slope formula with those two sets of numbers. Like the second y value 15 minus the first y value 5 over the second x value, which is also 15, minus the first x value, which is 0. So we go ahead and do our subtracting, like 10 on top and 15 on the bottom. Looks like in this case the slope can be reduced since they're both divisible by 5. And we get a slope of 2/3. So we want to put 2/3 where the m was in the equation. And now we know the equation of that line is y equals 2/3 x plus 5. We're working backwards. Not too long ago, we had the equation and we drew the graph. Now we're just working in reverse. We have the graph and we want to write the equation. If you were thinking that because it's a graph, you might do rise over run instead. That'd be perfectly good. Like we could see that to start at one point and move towards the other, we need to go down 2 spaces, but each space in this case is 5, so I'm going to go down 5, 10, and make a rise of -10. And from that corner point there, I would need to go to the left 3 spaces. These are also 5 each, so to the left 5, 10, 15 makes the run -15. And that would also simplify or reduce to 2/3. So either formula we use should give us the same slope. Here's a similar example below. Why don't you see if you could find the slope and the y-intercept and use that to write the equation of line number 2. When anybody's ready, let me know what the y-intercept of the line is this time. Let us know what you get from the y-intercept of number 2. Maddie or Paige, could you guys help us out there? Where does this line cross the y-axis?
5.
5? Good deal. So we'll have plus 5 again for our b. And we're thinking about slope this time. Remember, you can identify your points. You can go with rise over run either way. I maybe started at that upper point. I would need to go downward. So I'm thinking a rise of -1. And from that corner, I would need to go over to the right. 1, 2, 3, 4, 5, 6. 6 spaces. To the right is positive. So I've got a negative divided by a positive, which makes a negative. 1/6 doesn't reduce, so it's just a slope of -1/6. In other words, the equation is going to be y equals -1/6 x plus 5. How about some questions for us on our front page? Using the slope and y-intercept to write the equation. Those can be pretty quick and easy once you get the hang of it. We can use those same ideas to graph equations more quickly than we have in the past. Like for example, one here, if the equation is y equals 2/3 x plus 4, we should be able to tell from that equation what the slope is. Anybody remember which one is the slope there? Thinking about comparing it to y equals mx plus b. The slope, or m, would be the 2/3. We can also tell from the equation, just like we were working out the front side there, that the y-intercept is going to be at the b number, so 0, 4. Since we have a point 0, 4, we can begin with that. That's the b number, so begin with the b. In other words, let's put the point 0, 4 on the grid over here. And then let's use the slope to move. M for move. From that point, we have a rise of 2 and a run of 3. In other words, from that point, let's go up 2 spaces. That'll put us at the corner. And then we want to go over to the right 3 spaces. Then we'll be back on the line. So using that slope 2/3 to know that we need to go up 2 and over to the right 3. That pattern's going to continue. So from that new dot, if you wanted to make a few more, you could keep going up 2 to the right 3. Or for that matter, you could completely reverse the pattern. We could go down 2 and to the left 3. All of those points should be on our line. So once you have at least 2, or however many you like, you can connect the dots and draw in the line. There's some instructions up above telling what we just did. We began with the b. So we put the y-intercept on the graph, in other words. And then from the slope, or from that b, we moved up or down according to the rise, and then right or left according to the run, and made another point. Then we can connect the dots to drawing the line. Because we know this is a line, that's a shortcut. And when you get the hang of the shortcut, it can be really fast. Some books call this a 3-second line, because you can graph it so quickly if you know the slope and the y-intercept. What would you like to ask about that first? Let's try another one. Let's try y equals negative 2/5 x plus 3. So remember from the equation, we can identify the slope and the y-intercept. And then that will be enough information to graph the line. Could somebody on Teams help us out with the slope and the y-intercept this time? Maybe Austin or Avery or Haley? Or Bria. Bria made it. Yay. So we're looking at a slope this time of negative 2/5 and a y-intercept of 0,3. Let's begin, B for begin with the B number. So we're going to start at 0,3 on the y-axis. And now, according to the slope, we'll think about our rise and our run. Since the slope's negative this time, we know the line overall should end up tilting downward instead of upward. And the way to do that is going to be to use the negative with the top number. So from the point we already plotted, let's move down 2 spaces since the rise is negative 2. And then to the right 5 spaces since the run is 5. So for the rise, we're going to go down 2. And for the run, we're going to go right 5. In other words, put the negative with the top number. You don't want to make the top and the bottom negative, just one or the other. So with the top number, we'd go down and then right. Or if you were thinking of it with the bottom number instead, you could go up and then left. Those will both be points on our line. So once we have at least 2 points, even more if you like, we can connect the dots. And you will see that downward line we were expecting. So a little tip there, if we have a negative slope, put the negative with the top number and keep the bottom number positive, like negative 2 over positive 5. One other thing we might come across is a slope that looks like a whole number. So maybe for number 3, we'll write down y equals 6x minus 2. Take a second to see what the slope and the y-intercept are this time. Slope is 6, y-intercept would be 0, negative 2. So we're going to begin with B, the negative 2. From the origin, we're going to go down 2 spaces, make our first point. And then how can we think about 6 as a fraction, since we need a rise and a run? How do you make a fraction out of a whole number? Like maybe from that point I go up 6 spaces since I've got a positive 6, but then I need to know how far right or left over to go. If I want to make a fraction out of a whole number, I can always put it over 1. In other words, from that dot we already made, let's go up 6 spaces and then over to the right 1 space. It's going to make a pretty steep line. Up 6, right 1. Or we can go exactly opposite. We could go down 6 and left 1. All of those points will end up on the same line. So we get this fairly steep upward line. As far as slope goes, 6 is a pretty big number. 6 is a pretty big slope. So that's our line graphing shortcut. It hinges on the idea that we know the slope is a y-intercept. Feel free to use it anytime you can to make your graphs more quickly. What do you see on that page you'd like to double check? Well, I think we'll get a chance to practice that a bit more as we go, starting with this application on the next page. In other words, a problem where this information is used. You'll see something similar on homework. I think I copied this graph right here from a homework problem. So check out the story up above. It says, Milo Janis owns a weight loss clinic. He charges clients a one-time membership fee. He also charges per pound of weight lost. So we've got this one-time fee and an extra charge based on how much weight you lose. Therefore, the more successful he is at helping his clients, the more income he receives. The graph below shows a client's cost for losing weight. So across the bottom, the x-axis, we have the number of pounds. If someone loses 0 pounds, we can look straight up and find the cost, or 10, or 20, or 30. Because on the y-axis, we do have the cost in dollars. Might be helpful to notice what the tick marks represent. Like if this 30 is the first number shown on the x-axis, then we could think about what these blank ones must have been before it. If that goes from 0 to 30, this one must be 10, that one must be 20. In other words, each block represents 10 pounds. And we might need to think about something similar going up the side, because 200 is the first number that we see. So we know halfway to that would be 100. And that means each mark must represent 20, since there's 5 of them leading up to 100. So we just need to do a little investigating, see what the graph is telling us, see what the units are. Looks like as we go up, each square represents $20. So first thing they want us to do is write an equation, just like we've been working on. Should be in the case that we can use that y equals mx plus b again. In other words, from the graph, could we figure out what the y-intercept b is and what the slope m is? If we could, then we could just fill in those numbers like we did on the first page, and we have our graph. So let me give you a second to see from the graph if you can figure out what to put in for the y-intercept and what to put in for the slope. For the y-intercept, we want to look and see where that line hits the y-axis. And it's maybe a little hard to know for sure, but they do let us know that that point there is at 70. So our equation is going to end with plus 70. In other words, 70 goes in place of the b. The rest of the equation is going to look like y equals x plus 70. And that something will be the slope. So we can pick any 2 points we want. I was starting to work with rise over run over here. You could use the ordered pairs and x's and y's instead if you'd rather. I started at this top point here, which means I need to go down 3 squares. And we saw that each square represents 20, so that'd be down 20, 40, 60. That would make my rise negative 60. And then from that corner, I would need to go over to the left 2 squares. We saw that each square going this way represents 10. So that makes the run minus 20. Negative divided by negative makes a positive. 60 divided by 20 makes 3. Looks like the slope is 3. So our equation we can finish off now. Y equals 3x plus 70. Let me know if you would like to double check anything about that so far. And we'll see about using it to answer part B. So in part B, they're wanting us to use this equation like a formula. The equation, you might recall, represents the cost, because Y stands for cost, of a client who loses X pounds, so X is the number of pounds. In other words, if I know a number of pounds, I can plug it in here, multiply by 3, and then add on 70 to see how much that would cost. In part B, they want us to use the equation like a formula to figure out the cost for a client who loses 15 pounds. So 15 is going to be the X, and we'll just plug it in right there. In other words, take 3 times 15, add on 70, and that'll give us our answer. The equation would let us know what the cost would be for any number of pounds, like 15. So plugging 15 in for X means 3 times 15, which is 45, and then plus 70. 45 plus 70 makes 115. So if someone lost 15 pounds, it would cost them $115 to be a part of the clinic. One of the things we're supposed to do in this class is see how to use lines and linear equations to represent applications or situations. So here's an application where a line is used. How about some questions for us on that page? Well, when we flip over, we're going to see a different way to write equations of lines. We have a formula called the point slope formula. And the time that we need to use this is if we don't know the y-intercept. Everything so far gave us the y-intercept. So we use that nice, quick, easy way to do it. But when you don't know the y-intercept, we need a backup plan. So for when you don't know the y-intercept. The point slope formula gets its name because what we need is a point like x comma y and a slope m in order to use it. Those are the numbers we need to plug in. The formula looks like this: y minus y1 equals m times x minus x1. The point that we have to work with is going to be the x1 and the y1, so it'll go here and here. And then the slope, of course, is the m, so that'll go there. This is actually not a brand new formula for us. It's just our slope formula in a different form. So you might imagine for a second if we rearrange to get the m by itself. That means I need to get rid of all the stuff that's multiplied by. I'd get rid of it by dividing, so all these x's would end up underneath all these y's. And it'd look like our old slope formula. Y minus y over x minus x. It's just a rearranged version of our slope formula. So we've got a couple problems down below where we can try it out. First one's asking us to write the equation on the line with a slope of 6 that passes through the point 3, 3. So we have exactly what we need. We have a point 3, 3. That'll be the x1 and the y1 numbers for our formula. And we've got the slope, 6. That'll replace the m. So let's write the formula down. Y minus y1 equals m times x minus x1. And remember what we said, this is the way to go if you don't have the y-intercept, which is the case in this problem. We don't have the y-intercept. We have a different point, 3, 3. You can tell it's not on the y-axis because there's no 0 in the first spot. Since there's no 0, we need to use this different formula instead of the b. So when we go to plug everything in, we're going to leave a y and a minus at the beginning of the formula. Instead of y1, we'll from the point, so that'll be y minus 3. And then on the other side of the equal sign, we want to start with the m number. That'll be 6, parentheses, and then leave the x and the minus also. That'll be part of our formula, our equation when we're done. But instead of x1, we'll put the number from the point. So that'll be x minus 3 in the parentheses. Take just a second to look all that over, see if you can understand where it came from. We're just using that formula from up above. We're taking the point they gave us and putting it in place of the x1 and the y1. And we're taking the slope they gave us and putting it in place of the m. So the equation then usually needs to be simplified a little bit. A good way to get started is distributing. So y minus 3 equals 6x minus 18. Looks a little bit simpler without those parentheses there. You might have noticed also in the instructions it says write your answer in standard form. So down at the bottom we've got a box where we can show what standard form is. Standard form is the x and y are together on the left side of the equal sign, like we've seen a lot of times in our equations. That would be as opposed to when the y is by itself. Y equals mx plus b is the other form that we see a lot. That was our slope-intercept form. So those are the two ways we might be asked to write answers at times, slope-intercept form or standard form. What they asked for this time is standard form. So let's make sure we put our x and our y both over on the left side of the equal sign. And then any extra numbers we have will stay on the right. Let's see what we have so far. So far, the x is on the right side of the equal sign, and that's not where we want it. We want it on the left. So let's think about what it would take to get rid of it on the right and move it over to the left. What it would take is subtracting the 6x. So let's subtract 6x from both sides to move it from the right side to the left side. The y is already on the left side where we want it, so I'm going to leave that. Think about bringing it down when I regroup everything here in a second. And then all these extra numbers, like the minus 3 and the minus 18, we want them all together on the right side. So the minus 18 is okay, but the minus 3, we need to think about canceling it out and moving it over to the right side. Since it starts out as a minus, to cancel it out, we would add 3 to both sides. And then all of those numbers will be together on the right-hand side of the equal sign. So let's bring it all together. Let's start with our x. That was a negative 6x. And then our y. The y was positive, so let's make it negative 6x plus y equals. Remember, all this stuff has canceled out. So we just need to add up the negative 18 and the 3 to see what this equals. Negative 18 plus 3 makes negative 15. So, turns out the equation we're looking for in standard form is negative 6x plus y equals negative 15. That's a lot different than most things we've done recently, so feel free to ask anything you like about it. It takes a little getting used to. Or Paige, you guys want to check out anything about that first one? Or anybody on Teams? Austin, Haley, Avery, Bria, Rebecca, anything you guys would like to ask about that first one? Will I get a chance to try that out again in number 2? There's something a little more we need to do also for number 2, though. Notice what they want this time. It says find the equation of the line that passes through the points. And they give us 2 points that the line goes through. So we're still trying to write an equation. We still want it in standard form. But the information they gave us to start with is a little bit different. Remember we said to use our formula up here. We need a point and we need a slope. They gave us 2 points, but they didn't give us any slope. So it's really up to us to find that slope to get started, which is no problem since they gave us a second point. In other words, let's find the slope first with that y2 minus y1 over x2 minus x1 formula. And then once we have it, we can plug it in to our y minus y1 equals m times x minus x1 formula. So we've got step number 1, and then step number 2. For step number 1, we want to just find the slope like we did back on Wednesday, subtracting our 2 y's. That's going to go on top, and then subtracting our 2 x values down below. Everybody's very quiet today. I could definitely use a little help when you find the slope here. Let me know what you get. 2. 2 sounds good. Looks like a double negative on top makes 4 plus 6. And subtraction on the bottom. 10 over 5 makes 2. Great. Let's give everybody a minute to catch up with us there. Let us know if you need help finding that slope of 2. Anything we can help out with there? So from here, it's going to be like the previous problem. Now, let's put the place of the m. Yeah, Rebecca. Anything we can help out with, Rebecca?
No, I'm good. I accidentally pressed my microphone button. Sorry.
Oh, no sweat. No sweat. So now that we know the slope is 2, we want to put 2 in place of the m. And then we also need to use one of the points they gave us to put in place of the x1 and the y1. It honestly does not matter which one, so if you think one looks a little easier than the other, go for it. A lot of folks tell me they choose maybe the second point because there are no negatives, but either one is fine. So we're wanting to take y minus our y number equals 2 times x minus our x number. So decide if you want to go with point number 1 or point number 2. I think I'll use the 7 and the 4, avoid those extra negatives. So it'll be y minus 4 equals 2 times x minus 7. If you went with the 2 and the negative 6s, no problem. And like we did back on number 1, let's distribute and get rid of the parentheses. Then think about moving everything around so that the x and the y are together on the left. And the extra numbers are all gathered over on the right. So distributing, that gives me y minus 4 equals 2x minus 14. The things that are going to need to be moved are the 2x and the minus 4. I think you'll find as you do more and more of these, that's the same things that need to be moved every time. The x is always on the wrong side, and there's always an extra number on the left that needs to be moved. So let's subtract 2x from both sides, get rid of that. Add 4 to both sides, get rid of that. And as you write your final answer, think about putting the x's first, and then the y's, then the equal sign, and then the extra number. So x's first, that'd be the negative 2x. Y's next would be the plus y. Then the equal sign, and now negative 14 plus 4 adds up to negative 10. So that'd be our answer in standard form. Negative 2x plus y equals negative 10. Taking the standard form in action a little bit now, what you'll see is the a is usually some number, like the negative 2 there. The b is going to be some number, like the invisible 1 here. And the c also. So a, b, and c are numbers. And what we want in standard form is none of them to be fractions. So if you happen to have any fractions, you'd want to get rid of those, but not sure that'll even come up for us. We should be good to go. If you happen to be heading to Math 97, you might even have more restrictions, like in future classes, sometimes they don't want a to be negative. So there's just some conditions or criteria we have to work with and try to meet. So back up above number 1, just took one step because we had the slope. But number 2, we needed to find the slope first, so that added an extra step at the beginning. Got our new line writing formula to use anytime we don't know the y-intercept. Anytime we don't have a b number. How about some questions for us on that page? Kind of a doozy. A lot to get used to at first, perhaps. When we flip to the next page, I think we'll have a chance to practice a couple of the different things we've been looking at. Ooh, let me peek ahead a little bit and see something. Yeah. Let's jump ahead to the next page where it says test yourself number 3 up at the top. And that way we'll get a chance to practice more of the new things just now. Like in number 1, they're asking us to write an equation where we do see the y-intercept. So that'd be a good one for y equals mx plus b. Number 2 is also asking us to write an equation, but this time we do not have the y-intercept, so that'd be a better one for y minus y1 equals m times x minus x1. And then down at number 4, we have a chance to try one of those 3-second graphs where we use the slope and the y-intercept. So let me give you a few minutes to try number 1 and number 2, and then we'll jump down to number 4. Maybe we don't start with number 1, so we can compare answers in a few minutes. You want to make sure you're on the right track. We need a little bit of a nudge. Remember, the y-intercept is a big help. Writing an equation when you have the graph like number 1. And rise over run would be a great way to find the slope. So how about number 1? Could anybody help us out with the slope? What did you get when you counted it up and over? 4/3. Sounds great. So y equals 4/3 x will get us started. Plus, where does this line cross the y-axis? See that point right there? Looks like it's halfway between the 2 and the 4, so it must be at 3. Y equals 4/3 x plus 3. If you need any help with that number 1 there, just let me know. Otherwise, try number 2 if you haven't already. And number 2, remember we're going to be plugging -7 in place of the m, and -3, -4 in place of the x1 and the y1. That's quite a few negatives, a lot to keep track of. Good time to slow down and be a little extra careful. Like where it says y minus y1. I want to keep the y, keep the minus, and then y1 is -4. So we're going to get a double negative there. Maybe you went ahead and wrote it down as y plus 4. That'd be great. Either y minus negative 4 or eventually y plus 4. On the other side then, we'll start with the negative 7. And inside the parentheses, keep the x and keep the minus. And notice the x number 1 is also a negative, so we'll have x minus negative 3. We'll want to change that double negative to a positive, so x plus 3 is what we end up with in the parentheses. Anybody need a little help getting started on that one? Do you have an answer for us, Austin? Well, we talked about doing a little bit of distributing. And then a little bit of rearranging. Because again, they asked for it in standard form. What are you going to get when you move everything around to put it into standard form? It's going to be when I move that negative 7x over to the left side, it turns out positive. And then we'll add on the y that's already over on the left-hand side. When I move that 4 over to the right-hand side, it's going to be a minus. So we'll end up with 7x plus y equals negative 25. Let me know what we can help out with on number 2. Number 3 happens to be a lot like the first one. If you were looking for some more practice like number 1, you might jot this answer down. Make sure you can come up with it. Okay, why don't you move on down to number 4 if you haven't already. Try making that quick graph. Try using our shortcut to graph y equals 1/2 x minus 3. Looks like a slope of 1/2 and a y-intercept of negative 3. Where would you start to make the line? Start at B4 begins. So start at that negative 3 on the y-axis. And from there, according to the slope, what should we do for our moving? We should go, there's 1 on top, so we're going to rise or move up 1 square. And a 2 on the bottom, so we're going to run or move to the right 2 squares. The pattern for this line is up 1 over 2. Can continue repeating that as many times as you like. You can also reverse it, down 1, left 2. Connecting all those dots, we'll see where our run goes. How about some questions for us on number 4? That's the 3 main things from this section. We want to be able to write equations with y equals mx plus b. We want to be able to write equations with our point slope form. And we want to be able to graph equations with the slope and y-intercept. On the back of that page, we have a place to kind of keep track of all the formulas for chapter 3. So one of the things that throws people off, confuses people a little bit with this chapter is just keeping track of our different formulas. So you might recall from our last lesson, 3.4, we had 3 slope formulas. Why don't you see how many of those 3 you remember? What you can write down slope formulas from last time. What are we talking about anyway? What comes to mind? Things like y2 minus y1 over x2 minus x1, that was our first one. And rise over run. That's what we used for ordered pairs or for graphs, but when we had an equation instead, we thought of it as y equals mx plus b. And in fact, that's also the first formula we use to write equations today when we do the slope and y-intercept. There were 2 other forms we used for our equations today. See if you could remember a formula or a form to fill out, finish out those 3. They all had names like the one we already wrote there, that was slope-intercept. There was another one called point slope, and a third one called standard form. So point slope is the one we used to write equations when we did not know b. And standard is how we wrote our answers when we found those equations. So all of those formulas help us out. Most lines that tilt upward or downward are going to follow those formulas, but we did see some special lines like vertical and horizontal that kind of act their own way. So we might want to think about those separately. Maybe test yourself and see if you can remember which one is which. Maybe if you could draw a vertical and a horizontal line there. And start to think about what we know about the equation and the slope of each one. The equations were really short. They had a letter and an equal sign and a number. The letter would tell us which axis it crossed. Like for a vertical line, it crosses the x-axis. And then whatever number it crosses at would be on the other side. For instance, this one would be x equals 4. On the other hand, a horizontal line crosses the y-axis. So its equation would be y equal the number where it crosses. I think I put mine at 3. That one would be y equals 3. And when we talked about slope last time, we imagined maybe climbing on a horizontal line and walking along it. You would not be going upward or downward. So the slope was not positive or negative. Do you remember what it was? Not positive or negative. The slope would be 0. If we had tried to walk along a horizontal line, it'd be a disaster. You're not able to calculate the slope because it's undefined. So that page there ends up being kind of a good summary.